Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics and class 10, chapter number 10, light, reflection and refraction. Topics: numerical problems related to laws of reflection and plane mirror, parts of spherical mirror. Under the parts of spherical mirror, we are going to see what is meant by focus and focal length. The first topic, numerical problems related to laws of reflection. You know that there are the two laws of reflection. The first one is the angle of incidence is equal to the angle of reflection. That means angle I equal to angle R. The second one, the incident ray, the normal to the mirror at the point of incidence and the reflector ray all lie in the same plane. So these are the two laws of reflection. Before going to see the numerical problems, you have to know what is meant by I, R and some other angles. And look at this image. The plane mirror is kept in the horizontal direction. When the light ray fall on the plane mirror, it reflect back. So there are the two rays, one is incident ray and another one is reflector ray. If you draw the normal line between incident ray and reflector ray, there are the four angles. The one angle is I. The I is nothing but angle between the normal line and the incident ray, or that is angle between normal line and reflector ray, or we call it as angle of reflection. The third angle, that is angle between mirror surface and incident ray. The fourth angle, angle between mirror surface and reflector ray. I hope you understood. There are the four angles. The first angle is angle of incidence. That is angle between the normal line and incident ray. The second angle, angle of reflection. Angle between normal line and reflector ray. The third one, angle between mirror surface and incident ray. The fourth angle, angle between mirror surface and reflector ray. And also you know that if you take for the straight line, the total angle is 180 degree. The angle between normal line to plane mirror surface, that is 90. The question number 1, a ray of light is incident on a plane mirror at an angle of 30 degree. What is the angle of reflection? You have to draw a plane mirror. Here a ray of light is incident on a plane mirror at the angle of 30 degree. So the angle of incidence is 30 degree. So what is the angle of reflection? Listen the solution. They given angle of incidence I equal to 30 degree. We have to find what is the angle of reflection R. In a solution, by second law of reflection, we know that angle I equal to angle R. Here we know that angle I. The angle I is 30 degree. So the angle R also 30 degree. So the answer is angle of reflection R equal to 30 degree. The next question, a ray of light strikes a plane mirror at an angle of 40 degree to the mirror surface. What will be the angle of reflection? In a solution, you have to draw a plane mirror and a light ray is incident. The angle between the incident ray and mirror surface is 40 degree. Here they are not given the angle of incidence. They given the angle between the incident ray and mirror surface is 40 degree. So what will be the angle of reflection? The solution, they given angle between incident ray and plane mirror surface is 40 degree. We know angle between normal line to plane mirror surface is 90. Already we know that. What we have to find? We have to find the angle of reflection. How we have to find angle of reflection? If we know the angle of incidence, it is equal to the angle of reflection. So we have to calculate angle of incidence also. So we have to find angle of incidence I equal to what and angle of reflection R equal to what. The solution, angle between incident ray and plane mirror surface is 40 degree. So how to calculate I? I equal to the total angle is 90. They given the angle between incident ray and a plane mirror. So that is 40. 90 minus 40, 50. So the angle of incidence is 50. But we have to calculate what will be the angle of reflection. By second law of reflection, we know that angle I equal to angle R. So the angle of reflection is the angle of reflection also 50 degree. I hope you understood. Here, one thing is very important. Read the question carefully and what angle they given in the question. The next question, a ray of light strikes a plane mirror such that the angle of incidence is 30 degree. What angle does the reflected ray make with the mirror surface? Here they given directly the angle of incidence is 30 degree, but you have to calculate what is the angle between the reflected ray and mirror surface. So the solution, they given angle of incidence I equal to 30 degree. Here the question mark not will come. We have to find angle between reflector ray and plane mirror surface. And angle of reflection also we have to calculate. Then only we can calculate angle between reflector ray and plane mirror surface. The solution I equal to 30 degree, we know that by second law of reflection, angle I equal to angle R. So the angle of reflection R equal to 30 degree. We know the term angle between the normal line to the mirror surface is 90. So angle between reflector ray and plane mirror surface is, you have to subtract 90 minus angle of reflection. So the angle of reflection is 30. So 90 degree minus 30 equal to 60 degree. So this is the angle between the reflector ray and plane mirror surface. The next question, an incident ray makes an angle 35 degree with the surface of a plane mirror. What is the angle of reflection? So the given angle between the incident ray and the plane mirror is 35 degree. We have to calculate angle of reflection. And we know the term angle between the normal line and the plane mirror surface is 90. So the solution, angle of incidence I equal to 90 minus 35. 90 minus 35, we got 55. So the angle of incidence I equal to 55 means the angle of reflection also 55. By the second law of reflection, angle I equal to angle R. So the angle of reflection R equal to 55. The next question, a ray of light which is incident normally or perpendicularly on a plane mirror is a reflected ray back along the same path, because angle of incidence as well as the angle of reflection for such ray of light are 0. Look at this image. Here I drawn the plane mirror. When a light strike on a plane mirror perpendicular to a plane mirror or in a normal to the plane mirror, here the incident ray and reflector ray both are in the same path. So here there is no angle of incidence, there is no angle of reflection. So the angle of incidence and angle of reflection is 0. And also the reflector ray, the incident ray are in the same path. Here I drawn the two arrow marks. No, the one arrow mark represent incident ray, the another arrow mark represent the reflector ray. This is a very important one in this exercise. A light ray is incident on a plane mirror, making an angle of 90° with the mirror surface. The angle of reflection for this ray of light will be 0. How you say that the angle of reflection for this ray of light will be 0? Because the light ray is incident on a plane mirror, making an angle 90° with the mirror surface. If a 90° means here there is no angle of reflection. So the angle of reflection is 0. The second one, numerical problem related to the plane mirror. You know that the properties of image formed by a plane mirror. What are the properties of image formed by a plane mirror? The first one is it always form virtual and direct image. The size of the image is equal to the size of the object. And the distance between the object to the mirror is equal to the mirror to the image. And also the image is always laterally inverted. And look at the first question. A toy is placed at 10 centimeter in front of a plane mirror. What is the distance of image from the mirror? So here they asked the distance. You know the properties of in a plane mirror, the distance related to the point. What is the distance related to the point? The distance between the object to the mirror is equal to the distance between the mirror to the image. So here a toy is placed at 10 centimeter in front of a plane mirror. So what is the distance of image from the mirror? That is also 10 centimeter from the mirror. So distance of image from a mirror equal to distance of object from the mirror. So the answer is 10 centimeter. The second question, a boy with a mouth 5 centimeter wide stand 2 meter away from a plane mirror. Where is his image and how wide is the image of his mouth? You know that in a plane mirror forms virtual and erect image. So if the mouth is 5 centimeter wide means the image also 5 centimeter wide. So the image will form 2 meter behind the mirror and the width of the image of the boy mouth will be 5 centimeter. The object is always placed in front of the mirror. The image is always formed behind the mirror. The next one, David is observing his image in a plane mirror. The distance between the mirror and his image is 4 meter. If he moves 1 meter towards the mirror, then the distance between David and his image will be, what is that? Look at the solution. Here I drawn the plane mirror and the David is the object. From the plane mirror to object distance is 4 meter. So the image also formed behind the mirror also 4 meter. But if he moves 1 meter towards the mirror means the distance between the mirror to the boy is 3 meter now. So the image also formed 3 meter behind the mirror. Now we have to calculate the distance between the David and his image. That means the original object to in image distance is what is that? So the distance of David from his image will be 6 meter. How? The distance between the mirror to object, the David is 3 meter. The distance between the mirror to his image is 3 meter. So the total distance from the original object David to his image is 6 meter. The next topic, parts of a spherical mirror. The last class I thought the some parts of a spherical mirror, the one is pole, second one center of curvature, principal axis, radius of curvature. So what is the pole? The center point of the mirror is called pole. What is the center of curvature? If you draw the imaginary sphere to this mirror, you have center point for that sphere. So that center point is called center of curvature. What is meant by principal axis? The line joining center of curvature to the pole, that is called principal axis. What is radius of curvature? The distance between the pole to the center of curvature is radius of curvature. So the concave mirror also have this parts, convex mirror also have the same part. But what is the difference between this concave and convex? In a concave mirror, the center of curvature, radius of curvature, all are lie in the in front of the mirror. But if you take for in a convex mirror, radius of curvature, center of curvature all lie in the behind the mirror. The behind the mirror is nothing but it is opposite to the reflecting surface. This is one of the activity. From this activity we are going to learn what is meant by focus and focal length. Do not look at the sun directly or even into a mirror reflecting sunlight. It may damage your eyes. You know that we can't look the sun directly because the sun rays are very powerful rays. It can damage our eyes. For doing this activity, you have to take a concave mirror and also paper. Hold a concave mirror in your hand and direct its reflecting surface towards the sun. And look at this image. Here one boy took a concave mirror and he direct the concave mirror towards the sun. Direct the light reflected by the mirror onto a sheet of paper held close to the mirror. You have to take on paper and this paper must be close to the mirror. Move the sheet of paper back and forth gradually until you find on the paper sit a bright and sharp spot of light. Hold the mirror and the paper in the same position for a few minutes. What do you observe? Why? And look at this image. Here this boy hold a concave mirror towards the sun. The sunlight is fall on that paper at a particular point and the shape of that point is as like as a sun. So if you hold the mirror and the paper the same position for a few minutes, so what will happen? Definitely the fire will occur. The paper at first begins to burn, producing smoke. Eventually, it may even catch fire. Why does it burn? The light from the sun is converged at a point as a sharp, bright spot by the mirror. In fact, this spot of light is the image of the sun on the sheet of paper. This point is the focus of the concave mirror. The heat produced due to the concentration of your sunlight ignites the paper. The distance of this image from the position of the mirror gives the approximate value of focal length of the mirror. And look at the image. Here I given the two image. The first image, you know that I already said that the spot is looking like as a sun. So that is nothing but it is the image of the sun. When we hold the paper and the mirror for few minutes in the same position, the fire will occur. Look at the second image. Here the sunlight fall on the mirror. The light come to the earth as a parallel rays. When it fall on the concave mirror, after a reflection, all the reflector ray are meet at one point. That point is called focus. The distance between the mirror to that focus is called focal length. Are you understand what is meant by focus and focal length? The bright spot appear on the paper, no? That spot is called focus. The distance between the bright spot to the concave mirror, that is called focal length. So only I given the distance of this image from the position of the mirror gives the approximate value of a focal length of the mirror. So let us try to understand this observation with the help of ray diagram. Observe figure A closely. Here the first diagram, the sunlight comes to the earth as a parallel rays. It fall on the concave mirror. After reflected, all the rays are meet at the one point. That point is called focus. So how to draw the ray diagram for this image? Here I took AB, that is sun. You imagine that that is a sun. And the light coming from the sun or fall on the mirror, that is incident ray. After striking on the mirror, it reflected back. All the reflected ray are meet at one point. That point is focus. It is represented by the letter F. So how to draw the ray diagram for this image? You have to draw a concave mirror and you have to place to the object at infinity. Why I written infinity? Because the distance of the sun is infinity from our earth. But the light ray from the sun or reached at that concave mirror. After reflection, it meet at one point. That point is called focus. A number of rays parallel to the principal axis are falling on a concave mirror. Observe the reflector rays. They are all meeting or intersecting at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. Why I am saying that the principal focus? Because this focus is lying on the line of principal axis.